Hello everyone, this is Mohammed Alshehri, and today I'm presenting Hacking from the Sky. So I'll go over 8 main points. First, I'll introduce myself. Then I'll give you an introduction about the project. Then I'll describe the project, talk about the significance of the project, and we will discuss how to start flying drones in New York State. Then I'll go over my journey of designing this project. Then we will watch a demo together and talk about the features the drone has and the cost. My name is Mohammed Alshehri, and I'm a penetration tester. As you can see, my experiences in security are mainly on penetration testing. So drones have been used in a wide range of civilian and military applications and missions. These unmanaged aircraft systems are able to carry many components according to the kind of their purposes. Optimizing drones to perform specific tasks has been the attention of researchers in order to increase the efficiency of drones. This has led to the development and invention of a wide range of flying vehicles. And these wide range of flying vehicles have different capabilities. Currently, these flying inventions are in use in photography, videography, mapping, warehouse operation, emergency responses, and many other activities. The heavy development of drones attracted many cybersecurity specialists to start investigating this technology. As a result, various papers have reviewed different aspects of drones to improve their security. The main focus of the majority of the published security-focused papers is to present the security flaws found in drones. Not that many papers address the possible usage of drones offensively. And here where this project fills the gap. So the story behind this project is one day, Bill Stackwell, Rob Olson, and I were performing an external on-site penetration testing for a client. I was in a co-op and they were mentoring me. The client was in a multi-story building, and we had to find a way to get closer to their access point to perform common Wi-Fi attacks. However, we struggled to get close to the client's access points due to their hard-to-reach location. The idea came from that event. There was a problem that I needed to solve, so I turned that problem into a project, and here I am presenting my solution. The project idea is to design a cost-effective solution that can carry cyber attacks. The main goals I want the drone to achieve are to bypass physical obstacles, conduct network services attacks, conduct wireless attacks, and Bluetooth attacks. And of course, I want it to be controllable using secure methods. So the significance of this project. So I want it to be a point of reference. Often implementations of red team drones are closed source or expensive to design, and the amount of open source penetration testing drones is rare. So this proposed project serves as a point of reference to show one way of designing a drone packaged with different penetration testing technologies. The project and its documentation are positive contributions to field of penetration testing. The project's documentations will be published so that other penetration testers and possibly red teamers can benefit from it and easily recreate the same device or a similar device. So it's not just about developing a design to assist on-site engagements, but the other important purpose of this project is to challenge myself. So challenging myself would be by researching a new world, the world of UAVs, and researching new methods to improve them. So before flying a drone, so if you're planning to fly a drone in New York State, there are a couple of things that you need to do. One is you need to get a remote pilot certification, and you can get that from FAA website, the FAA website. Two, you need to register your drone. If you're planning to fly it in public places, that is a requirement. And that's what I actually had to do. I had to take the certificate, and also I registered my drone. So the journey. The first step was designing 3D designs. The intention was to use these 3D designs in the planning phase to build extensions that can hold equipment on the drone. So my 3D designer friend, whose name is also Mohammed, helped me and advised me design a couple of 3D prototypes. So thank you, Mohammed, if you are in this meeting. So these 3D designs helped me formulate a plan to start the project. So after the planning phase, I started to think about how we can design the thing that will hold the hacking device and its equipment. During this phase, I started by thinking about using a printed plastic design, but the idea was quickly changed because of a number of reasons. The main one is because it adds an additional weight to the drone, and based on my tests, the drone motors that I have only can carry 250 grams, and I needed that weight for other things, and I will explain them later. Then I moved to thinking about using fabric. I decided to use fabric because it's very light. The idea was to design something like a bag and put everything I need in the bag. But that also didn't work because it was shaking the drone very badly and made it unsteady. The third option was to use foam, and that actually worked. Just using foam and tape was a significant way to hold everything together. It was a good idea, and the foam was able to hold all the equipment. And this is how it looked like. As you can see, the phone was in the bottom, on the top was the antenna, and they were connected using a cable. Well, it almost worked. Let's look at the video. So as you can see, when I was trying to fly it, it was too heavy. The equipment on the drone were too heavy. To solve this problem, I needed to programmatically increase the motor speed and get rid of the foam. So I decided to attach everything together on the drone using only tape. And actually, before that, I performed some strength tests, and I found out that drone is only able to carry around 250 grams. The weight of the equipment on the drone came to be around 206 grams, which is less than the maximum weight the drone can carry. So I used an EXSI with two VMs. The first VM is a pfSense for OpenVPN, and an Ubuntu with OpenCV2. I will explain them later. I also used AWS instances for port forwarding, and I bought AR drone. I also used a phone to be the hacking platform. I used also an Xbox One joystick to control the drone. And I was given a wireless adapter from Rob Olsen. Also, finally, I used an adapter to connect the wireless adapter to the phone. So why do I use virtual machines? Starting from pfSense, the pfSense was running OpenVPN service, allowing authorized clients to enter the local network. The reason behind choosing pfSense is because it helps routing the internal network and can easily establish a VPN service. The second VM is a normal Ubuntu VM. This VM is used to run the drone's camera feed. The reason behind using this VM is that the camera feed can be shared and observed by multiple members of the pentest team. Also, if the pentesters want to record the feed, they can do it easily via the VM instead of using the drone and using its power to do that. The Ubuntu VM runs a script called network. This script is responsible for receiving data from the drone and the joystick, and it will be explained later. So the drone. Before buying a drone, I had two important rules to follow. The first one is the drone has to be cheap. I'm paying out of my pocket and I don't want to waste money. Also, I was sure that something bad will happen and I will break the drone, which means that I will need to buy another one. And what I expected actually happened. I broke the first drone and in the first month, and I had to buy another one to continue the project. The second condition was I needed to be programmable. I wanted to build a custom way to control the drone and avoid vulnerabilities that comes from using normal RC transmitter. Following the tool rules, I decided to buy AR drone. It's cheap and customizable. So for the controller, I decided to use an Xbox One controller. The reason behind this choice is that I'm familiar with this controller, and there are many libraries online that can help me receive the controller's signals and convert them into commands that can be understood by the drone. The way this controller is used is by connecting it into a device that runs a script called joystick, which is a script I wrote, and it's also in the repo of the project. This script serializes the signals and send them to the Ubuntu VM. So I also used AWS. It was used to redirect traffic to my local server, which is behind a NAT network. If your VPN server has a public IP, I don't think you need AWS in this case. But in my case, I needed it for the first 2 months. To do this, I used an open source tool called Tunnel Manager, which is a tool I wrote to help red teamers redirect traffic from AWS nodes to internal hosts. The hacking platform. So the hacking platform I used is just a OnePlus 3. The phone I used doesn't allow using the root user by default, which means I had to root the device to be able to use its full capabilities. After rooting the device, I installed Chroot and Kali NetHunter, which is an open source mobile penetration testing platform. The phone is connected to the internet and connected to my OpenVPN server, which allows other penetration testers to connect to the phone and control the drone over 4G. So let's look at the full picture. This is the final topology with everything connected together. As you can see, starting from the right, there are 2 laptops, one connected to the server via AWS and the other is connected directly via the LAN network. They both can communicate with Ubuntu, which means they both can control the drone and observe the camera feed via RDP. I had 2 laptops on the right side just to show that you can control the drone over the internet or if you are directly connected to the LAN network. The drone in the left side is connected to Kali, and Kali is using 4G to connect to the VPN. And it sends all of its data to AWS, which redirects everything to pfSense, which redirects everything again to Ubuntu. This is how things work in the backend. So let's see how we can use it to perform an attack. So I will show a demo, but before I start with the demo, I would like to explain what's going to happen, since there are a lot of things that will be in the video. As you can see, the laptop on the right side of the screen is connected to AWS, which redirects the traffic to pfSense, and it redirects it to Ubuntu. That will be me. I'll be controlling the laptop. Kali is also connected to the same way, and we have the access point in the left side and a client connected to the access point. These 2 icons represent our client or the person that we want to ethically try to get into their network. The aim here is to fly the drone to the target access point and perform a deauthentication attack, then capture new handshake and then crack them. I would like to also explain the environment. I was at RIT's gym in one of the racquetball courts. I have placed an access point and a device in the 2nd floor, as you can see in the left side. My plan is to connect the drone to my VPN via 4G, and then control it and fly it next to the target machine using the joystick I will have. So what's going to happen is I'm going to fly it, go over next to the access point, capture or send a deauthentication attack, capture a handshake, then crack everything and get back. So the demo. So here I'm showing me connecting to the access point, and I'm on the second floor now. I just connected to the access point, and we'll leave the device next to the access point. And I'm zooming in and showing my drone and where I'm gonna sit. So before moving on, I need to explain what's happening here. On the right side is my view. Here is I'm gonna show the joystick and how I control it, and also gonna show the feed of the camera on my laptop. In the left top corner is the GoPro view. It captures the movement of the drone and how I'm gonna elevate it and capture the traffic from the wireless access point on the second floor and go back. In the bottom left corner is a session from the hacking platform, an SSH session from the hacking platform, and I'm gonna show how I used Wi-Fi T to hack into the network. And as you can see now, the drone is on the bottom and the access point is in the second floor. And I'm gonna fly it that direction. Clicking off. So now I'm gonna turn on the camera. As you can see, this is me controlling the camera on the laptop. So now I'm flying and increasing the altitude. So now it's hovering next to the target. This is an automated script that will capture the network, the targeted network, and perform multiple attacks at the same time and get the network as soon as possible. So it now performs a deauthentication attack to the tablet device, and it captured this. So now it will do, it will try to crack the handshake. And since it's an easy password, it was able to do it very quickly. And as you can see now, the password is 12345990. And I'm just gonna land it now. So what can you do using this drone? The first unique feature is the ability to control the drone from long distances. As long as there is an internet connection on both sides, the drone can be controlled. The second feature is the ability of using OpenVPN. Using encrypted channels means that it will be almost impossible for a third party to understand the traffic going between the drone and the controller in the VPN tunnel. The third useful feature is using a powerful CPU. Comparing this CPU with other CPUs in lightweight devices like Raspberry Pis, OnePlus CPU is way more powerful and useful. This gives an advantage to the penetration testers to use the phone together, so they can all SSH to the phone and control the drone or do whatever they want, or maybe try to attack different devices at the same time, like let's say the access points, Bluetooth devices, and other things. The fourth feature is, since the drone is controlled via Python and the camera feed is collected on the Ubuntu machine, the drone can be programmed to perform specific actions based on the camera feed. So an example for this is the drone can be programmed to return to base if a moving object approached it. Also, as shown in the demo, the drone is able to perform Wi-Fi attacks and, of course, Bluetooth attacks, since the phone is already shipped with Bluetooth adapter. And since it uses Kali, the drone can be used even further and perform Windows and Linux attacks after getting access to the network, and possibly drop payloads and establish persistence inside the compromised networks. Finally, I added a panic button feature, which tries to erase the data from the phone in case it gets captured. So there are a couple of things that I would like to highlight so the next person can learn from my mistakes. During the planning and designing phases, I was dependent on RIT 3D printers. And that was a mistake since many students use them. That means that it's hard to reserve a printer to print many prototypes. And for somebody like me, I'm not an expert in 3D printing, so I would need to print multiple ones. Plus my 3D printer friend is not always available. So that was the first mistake. If I'm gonna do it again and build another one, I would maybe buy my own 3D printer. And even though the idea of printing plastic attachments was canceled because of the limited weight, this was another reason why I canceled it, because of the availability of the 3D printers. So during the implementation phase, I faced another problem. The problem was that when I was planning for the project, I used Google to find out the weights of everything that I was gonna put on the drone. And it was fine, but I never double checked that when I was implementing everything together and putting everything together. That was a problem. The weights I found online were not accurate. So I kind of sacrificed some of the ideas that I wanted to implement on the drone, like, for example, dropping USB rubber duckies. So that idea was canceled, even though originally it was part of my vision. And the last phase, which is the testing phase, was the most horrifying phase. And here's why. I started by testing the drone at my apartment, which turned out to be a disaster. During the first month, I broke the drone's blades and I had to replace them. To solve this, Professor Bill Stackpole suggested that I fly the drone in the gym, which turned out to be a good idea. I resumed my tests there after taking the right permissions, of course. Also, during the testing phase, I didn't perfect the controlling mechanism that I invented. When I started testing the drone with all the weights on it, it behaved differently. And I didn't know that it will change its behavior. So I had to reprogram everything again. But unfortunately, that happened after I dropped the drone multiple times and I broke the first drone. I broke its core, so I had to replace it. During this whole project, I had to go through a lot to complete it. I'm used to command a device and the device does whatever I say. But in this project, there was more than a device interacting with each other and implementing something that interacts with the real world and thinking about many factors like wind, the motor's force, changing the position of the drone while taking care of the weight on it. It was a hard mission. It was always just networking and programming for me, but now it's more of networking, programming, and dealing with physics altogether. So it was a challenging project, but I am proud of it. So for the cost, I had to use AWS for the first 2 months because my server was behind a NATed network. And I use it mainly to forward traffic to my servers, my home servers. Now I don't use it anymore, but I had to use it for like 2 months and it cost me around $2, $1 to $2. Xbox One joystick, I got it from Facebook Market, which costs around 10. USB C to USB adapter, got it from Walmart, and it costs around 10. So the Wi-Fi adapter was borrowed from Professor Rob Olson. I didn't need to buy it. However, you can find it on Amazon for $28. The OnePlus device, I got it from a Facebook Marketplace. And I think this is one of the best decisions I made. It was for $80 and I got a really good device that can do way more than Raspberry Pis and other lightweight devices. Finally, the drone, it costs from ePay $150. And that brings the total to $261. I didn't actually include everything I bought because, like, for example, the first drone I broke, I didn't include it here. I also didn't include things like the battery of the drones because I had to increase them to optimize the drone. But in a perfect situation, I would say $261 would be the cost of this whole thing. You don't even need to use EXSI to run your instances. Everything can be in AWS and it wouldn't cost more than $3. Thank you. I hope that you liked my project. Any questions?